Good afternoon. We are going to do Chapter 6, Section 7, which is on transformations. Now, we've already gone over transformations and the rules, but now we're actually going to apply it to different types of graphs like radical graphs and parabola graphs. So for this first one, we're going to graph the equation f of x equals negative radical x plus 3 minus 1. So first thing you want to do is establish what your base graph is. In this case, y equals radical x. And I'm going to come over here on the right side of my page, and I'm going to draw a pair of axes. They don't have to be huge for this type of a graph. Radical graphs tend to be pretty compact. There we go. So we're going to be using what's called a point-to-point method, which means we're going to draw a graph, then do a transformation to the points, plot the new points, do a transformation to the next points, and so on. So we're going to apply each transformation to the points as we go along. So for the base graph, and again, you just kind of have to memorize this, 0, 0 is the end point. And then 1, 1, and of course square root of 4 is 2. So 1, 1, and 1, 2, 3, 4, up 2. And I'm not going to label the points on the graph today because it's going to get a little messy before we're done. Okay, so first thing we want to do is apply the graph, and we can, or apply the transformations to the graph. Let's start by going on the inside. And so again, we're going to switch here. Y equals the square root of x plus 3. Okay, what is this? This is a horizontal translation, -3 to the left. And remember, it's always going to be opposite with the x. So point to point, I'm going to take all the x's and I'm going to subtract 3. The y's are going to stay the same. Okay, so 0, 1, 2 will stay the same, but 0 minus 3 is -3, 1 minus 3 is -2, 4 minus 3 is a 1. Okay, I'm going to use green for this, a little bit of color coding. So 1, 2, 3, -3, 0, -2 up 1, and 1 up 2. There is our first transformation. Okay, the second one we're going to do is the reflection, which is the negative outside of the radical. And this is a reflection across the x-axis. And again, you have to memorize that the negative in front means across the x-axis. Negative inside is across the y. Okay, so to do this transformation, all the y's are going to change. So we're going to take all of the y variables and we're going to multiply them by a -1 because it's going to flip top to bottom. The y's will change. So -3, -2, and 1 do not change. 0 times a -1 is 0. 1 times -1 is -1. 2 times -1 is -2. All right, this one is going to be the red line. So 1, 2, 3, -3, 0 doesn't change. -2, -1, 1, -2. And as you can see, the green line has definitely reflected across the x-axis. Here is our x-axis line of reflection. Okay, so the last transformation that we have is in the y direction. So y equals negative radical x plus 3 minus 1. So this is a vertical translation down -1. So all of the y's, we're going to subtract 1 because we're going to translate this down. Okay, so x's don't change. -3, -2, 1. 0 minus 1 is -1. -1 minus 1 is -2. -2 minus 1 is -3. And this is going to be our blue and final graph. So -3, -1, -2, -2, 1, 1, 2, -3. And there is our final graph. Now just to run a test point, if x equals 1, 2, 3, we should be down -3. So if I substitute in a 1 into the original here, 1 plus 3 is 4, square root of 4 is 2, -2 minus 1 is -3. So that checks out. This would be called the point-to-point method. Sometimes people do point-to-point and they don't graph each stage. They just do the operations to the t-chart and then at the end graph the result. So that's a radical graph. Okay, our second example, we're going to do a parabola. So g of x equals -x plus 5 squared plus 2. Okay, so just to remind you, when we learned this, the order of things that you follow depends, you always want to go inside to outside, and your stretches or shrinks should come before your reflections if you have any. Okay, so the base of this graph is y equals x squared. And I'm going to draw a pair of axes. This is all going to be up above the x-axis. And this base graph, as I'm sure you know, if you draw the points for it, you have a vertex at 0, 0, and then 2 to the right, or 1 to the right, 1 to the left, so 1 and -1, both give us 1s. And then 2 and -2 give us 4s. So 1, 2, 1, 2, 3, 4, -2 up 4. There is our base graph. Okay, so first thing we're going to do is we're going to go ahead and there is no vertical stretch or shrink. There's nothing out there. So we're going to do the vertical translation up. So y equals x squared plus 2. On our point-to-point graph, all of our y's are going to get a 2 added to them. So 0, 1, -1, 2, and -2 do not change, but the y coordinates do. 0 plus 2 is 2, 1 plus 2 is 3, 3 again, 4 plus 2 is 6, 6 again. All right, this is going to be our green graph. So 0, 2, 1, 3, -1, 3, and then 2, 1, 2, 3, 4, 5, 6, and -2, 6. Notice when we're doing this how the branches of the graph slowly get close to each other as they go to infinity. Yeah, that's because they get straighter and straighter and they start to align with each other. Okay, now we're going to do the reflection. You always reflect and then translate. So we're going to do the -x squared. So, oh, I forgot to write in what this was. This was a vertical translation to up. This one is going to be a reflection across, and this one's on the inside this time, not the outside, so it's across the y-axis. Negative on the inside is across the y, negative on the outside is across the x. So that means that all of our x coordinates are going to be multiplied by a -1 because they are flipped over the y-axis. So my y's stay the same, 2, 3, 3, 6, 6. My x's get multiplied by a -1. So 0, 1 times -1 is -1. -1 times -1 is +1. 2 times -1 is -2. -2 times -1 is +2. All right, this is going to be our red graph. So let's plot these. So first off, 0, 2, that one doesn't change because it's sitting right on the y-axis. So when it flips, it just stays put. Negative 1, 1, 2, 3, 1, 1, 2, 3, 2, up to 6, and you go, wait a second. Those are the exact same points. Yes, that's because the axis of symmetry for this parabola is the y-axis. So when you rotate it across the y-axis here, it maps onto itself because it is symmetrical through the y-axis. That happens sometimes with parabolas. Okay, our last one, we're going to do the translation in the horizontal direction. Y equals negative x plus 5 squared. So this is a horizontal translation. And remember, it's always the opposite, negative 5 to the left. So we're going to take our x values and subtract 5. The y values will stay the same. So 0 minus 5 is negative 5. Negative 1 minus 5 is negative 6. 1 minus 5 is negative 4. Negative 2 minus 5 is negative 7. And 2 minus 5 is negative 3. The y's are the same, 2, 3, 3, 6, 6. Okay, this is our blue and final graph using point-to-point transformation. So negative 5, 2. 1, 2, 3, 4, 5. Up 2, that's our new vertex. Negative 6, 3. Negative 4, 3. Negative 7, 1, 2, 3, 4, 5, 6. And that is our final graph. Again, you can double check your points. This vertex is negative 5, positive 2, which matches here, negative 5, positive 2. So that checks out. So the graphs on these are going to use translations and reflections. We'll get into stretches and shrinks as we go along. Otherwise, have a good afternoon.